Okay, let's dive into the story of how a revolutionary new medicine gets managed. From the very moment it's conceived in a lab all the way to when it reaches a patient. And this isn't just a story about science, it's about the invisible digital system that's guarding it every single step of the way. And that question? Well, it's especially critical right now. See, we're not talking about some simple pill you just press in a factory. We're talking about incredibly advanced cell therapies, where the medicine itself is literally made of living cells. And that makes its journey from the lab to a person just unbelievably complex and, frankly, full of risk. So, how do you manage all that risk? Well, the answer is a really powerful piece of software called a LIMS. That's a laboratory information management system. The best way to think of it is as the lab's digital brain, or maybe like an air traffic control system for science. Its whole job is to track everything, enforce all the rules, and make sure absolutely nothing goes wrong. To really see how this works in action, we're going to follow the story of one single hypothetical batch of a cancer-fighting cell therapy. We'll just call it batch 001. Its entire life, from a tiny sample to a life-saving treatment, is about to be chronicled and controlled by this LIMS we're talking about. Okay, so here's the first thing that might surprise you. Before batch 001 even exists as a physical thing you can hold, its entire life story is already written. It's meticulously mapped out right inside the LIMS. It's a digital blueprint that's going to govern its entire existence.
And that blueprint is built from something called master data. This is kind of like the system's DNA. It's all the foundational, unchanging information that defines the drug. We're talking about what the product is, the exact criteria it has to meet, like, say, its purity, the step-by-step guides for every test, and a full schedule of every single test and sample required.
Now, this is really cool. You wouldn't think a name would be a big deal, but it's actually the first line of defense against a catastrophic mix-up. Look on the left, just total confusion waiting to happen. But on the right, you have a strict information-packed naming system. This isn't just about being neat, it's about making sure there's absolute clarity and traceability. No guesswork allowed. All right, so with that digital blueprint locked in place, our actual physical sample for batch 001 finally arrives in the lab. Now it's ready to be put through the testing gauntlet, and it's going to be guided and monitored at every single step by the LIMS. And this is where the lab analyst gets a digital co-pilot. It's called the Laboratory Execution System, or LES. And look, the LES doesn't just suggest things, it enforces them. It gives the analyst a digital worksheet, it forces them to follow the exact procedure, it automatically does the math, and it instantly checks the results against the rules in that master plan. There is just no room for error. So what is the LES actually checking for? It's testing for these things called critical quality attributes, or CQAs. For a living drug, these are the absolute essentials, the non-negotiables. Are the cells alive? Are they even the right cells? Do they actually work? Are they free of junk? And, the most important question, are they safe? For our batch 001, one of the most critical tests is viability. I mean, it makes sense, right? Dead cells can't fight cancer. The system knows, from that master data we talked about, that the specification is a hard line in the sand. At least 70% of the cells in this batch have to be alive and healthy for it to even be considered effective. So, here's the really crucial point. Every single click we've seen, every piece of data that's entered, every calculation, it's all being watched. There's a super strict set of rules governing this entire process to make sure that the digital record is completely unbreakable and trustworthy. Now, this whole process is governed by a strict set of rules. The big picture philosophy is called GXP, which just stands for good practice, and it basically means everything has to be documented and traceable. In the US, the FDA enforces this for digital systems with a specific rule called 21 CFR Part 11. These two things together, they're the foundation of trust. They're what makes a digital signature just as legally binding as one you sign with a pen. And to achieve that trust, all the data has to follow what are called the ALCOA Plus principles. It sounds fancy, but it's really just a simple checklist to make sure the data has integrity. Is it attributable? So do we know who did what and when? Is it legible, contemporaneous, meaning recorded in real time, original, and accurate? It's really the gold standard for data you can trust. And this slide just brilliantly shows what happens when you break those principles. If you enter results from memory a day later, that's not contemporaneous. If you share a login to approve something, that action isn't attributable to a specific person. And if you just delete failed tests and pretend they never happened, well, your data isn't complete. These are the exact human errors and shortcuts that a good LIMS is designed to prevent from ever happening. Okay, so all the tests are done, the rules have been followed, every box has been checked. Now it's time for the final verdict. Let's see how all this carefully managed data comes together to tell the critical story of our batch 001. After all the testing is complete and every single result has been reviewed and signed off on, the LIMS automatically does something amazing. It transforms thousands of individuals' scattered data points into one single, powerful, coherent document. And this document is called the Certificate of Analysis, or COA for short. You can think of it as the batch's final report card. As you can see, for each critical test, it clearly lists the required specification, the final result, and that all-important status. And for our batch 001, look at that. The cell viability came in at 86.6%, well above the 70% we needed. It's a pass.
And ultimately, this single piece of paper, or, digital paper, this is the culmination of our batch's entire digital journey. It provides the objective, traceable, and verifiable proof that's needed to make the final critical decision, to release this life-saving treatment so it can be given to a patient.
So this whole journey just shows the incredible power of a digital system to enforce quality and ensure patient safety. But it does leave us with a pretty interesting question to think about. If the system literally prevents you from breaking the rules, who's ultimately responsible for the quality? The scientists doing the work or the software watching over them? It's a fascinating balance between human expertise and the rise of the digital guardian.